Y vamos a continuar ahora con un tema que es de vital importancia para el desarrollo del sector agroalimentario y, por supuesto, es la agricultura, el campo. Y la agricultura va indudablemente ligada a la innovación y a la tecnología. Y en este sentido vamos a ver ahora más a fondo cómo la inteligencia artificial puede actuar como herramienta de apoyo para los agricultores, cómo puede hacer también que los jóvenes decidan quedarse en este sector primario y, además, cómo puede ser una herramienta que nos ayude a mejorar la falta o el problema de mano de obra que tenemos en muchos casos. Y en este sentido, I'd like to introduce now to a company that is empowering greenhouse growers with artificial intelligence. We have with us today Ernst van Bruggen, co-founder of Source.ag, and he's coming from the Netherlands. And Ernst in a country as Spain, where agriculture and the exports are at the core of our economy. We would really like to know more about how artificial intelligence can help us in solving these issues. Thank you, Ernst.
Thank you very much. Hello everyone, my name is Ernst van Bruggen. Yes, great, awesome. Hello everyone, my name is Ernst van Bruggen. I'm the co-founder and CPO of Source. Source is an AI company that develops smart software for greenhouse growers, both low and high tech, across the globe. We help growers adopt these AI solutions to improve their profitability and their scalability in their operations. Recently, there's been a lot of talk about AI, and it's quite a mystic term, right? So over the next 10 minutes, I'm going to take you through not only what does AI do or what can AI do, but also show a little bit of how AI works and how we approach these problems, specifically with the example of yield forecast. But first, let's take a step back and look a little bit at the trends that are currently affecting this industry across the world. Over the past 10 years, we've seen up to 40% reduction in yield for open field farming, which really has accelerated the transition to greenhouse growing. But at the same time, we've seen prices, producer prices, staying flat or even decreasing a little bit. And this can be explained to some extent by the power of the retailers in the value chain, being very large companies, consolidating still, and just putting a lot of pressure on the fragmented landscape of growers. At the same time, we have, through a rising middle class, it's becoming harder and harder to find low-skilled, high-quality labor to attract them, but also to retain them. But the industry is reacting. Growers are also expanding and consolidating to increase their size. As an example, you see a picture here of Agriport. It's a 750-hectare development that was built in the Netherlands over the past 15 years. And these high-tech greenhouses produce food for more than 20 million people. But you don't just see this in high-tech, you also see this in low and mid-tech, also very much here in Spain, Almeria region. And why does scaling help? Well, there's two main advantages. The first one is that it creates negotiation power, both on purchasing, so procurement, but also on price setting for produce. And it also gives the opportunity to pool resource and reduce your fixed cost. However, scaling up also increases complexity. And this is where forecasting becomes very, very important. It makes a difference between being a very reactive company and always firefighting to being a very proactive company and having vacation now and then. So, examples of where forecasting becomes important. As you grow, retailers expect more security of supply, more fixed contracts, further out in time instead of selling or buying at the spot market. Imagine having multiple facilities in multiple locations and then the complexity of labor planning, which is also a type of forecasting, of course. If you have a difference between your forecasted production and the actual demand, this can result in a lot of waste, which we see happening everywhere as well. And then an added complexity is that we have so many companies offering solutions in this space, and many of them, and it's hard for a grower to find out what can help me and how do I integrate this successfully in my operation. But information is key, and getting to actionable forecast requires a few steps. It doesn't just happen. And I'm going to take you through what those steps are and then apply them to the case of yield forecast. First thing you need to do is really digitize everything that is happening in your operation. So it's really about investing in data infrastructure. Once you have that data layer set up, you can start looking at things you want to have information about in the future to determine what will happen and why it will happen. Because as soon as you know why something is going to happen, you have the ability to control it and to improve your outcomes. So specifically for yield forecast, what do you need? To understand what is happening now, I need to have information about yield, but especially about how my plants develop. And at Source, the way we've solved this is by giving growers the ability to track a digital twin of their measurement plants in an iPad. Growers go into the field every single week and they measure every single measurement plant, so it's a sample of their total crop. And by doing so, they track the development and growth of every single fruit on every single measurement plant. And so what it gives them is a very accurate state of the crop as it is in that last moment of measurement. And we do this for tomato, we do this for pepper and for cucumber as well. Now we have the basis in place, right? We have the data infrastructure, we know what is happening. Now we can start training models to predict yield. And there's a lot of solutions out there that claim that they can solve yield, and many use an approach of a black box model. I'm sure that's a term you've heard before. A black box basically means that you don't really know what connections the model is making to predict a certain outcome. And it works more or less like this. I have a target that I want to predict. In this case, it's production, yield. And then I have data about everything that I think relates to that outcome. Temperature, radiation, leaf size, etc. If I ask an algorithm to predict yield based on that data, it will try to find relationships between those features, as we call them, and the outcome. So what it tries to do is find, for example, if I see temperature changing in the data, and I also see yield changing at a similar rate, then I attribute more weight in the algorithm to temperature as a predictor of yield. That's how these models work in a very, very simplified way. However, there's a huge risk to black box models because it doesn't, black box models do not explain the actual relationship between input and output, only correlation. And this can lead to huge problems, as you can see here. Because it turns out that the age of Miss America correlates really, really well with murders by steam, favors, and hot objects. So if I now ask an algorithm, if I feed this data to an algorithm, and I ask the algorithm, can you tell me how to decrease the number of murders? It will simply tell me, you have to reduce the age of Miss America. Now, regardless if I can do this or not, it's of course not gonna work, because these events are not actually related, right? The one doesn't really influence the other, as far as I know. And the same thing happens in yield forecast, because we have two different processes in the plant that govern yield forecast. We have fruit development, so this is the time it takes for a fruit to go from a flower to a harvestable fruit. That takes a certain amount of time. And we have fruit weight, so the increase in biomass for each fruit every single day. And these processes are independent, which means that the underlying drivers are different. Fruit weight is mostly impacted by radiation, photosynthesis, the partitioning of sugars across fruits, but very big component is the amount of sunlight that you receive, or that the plant receives. And temperature, fruit development is mainly explained by temperature. If I take a black box approach and I ask the model, can you tell me how to increase my fruit weight without making this distinction, it may tell me you have to increase temperature, which will not happen, or which will not result in an increase in fruit weight. And this is why a lot of these solutions struggle to, especially to deal with changing conditions. Right? If you've always done the same thing, you're able to predict. But if you're doing different things than you did before, then the model doesn't really know how to react. And so at Source, we use the biological relationships between environment and plant growth to train our models. So we have independent processes, independent models, that for each fruit on each measurement plant, we take the latest measurement and we simulate each day in the future how that particular fruit is going to develop, both on its development, so getting closer to being ripe, but also on the biomass increase. And so we can, for each day in the future, and here you see this tomato plant, you see for each day in the future that we generate a digital twin of the plant. And as a byproduct, we know at each day how many fruits are ready for harvest, and that gives the harvest forecast. So now I can predict yield, and I know what drives it. Can I use this information to actually change it? We do this, this goes down to optimization, and we do this already every single day. A lot of tools that we have in our daily life use this kind of technology. As an example, you have Google Maps. I can ask Google Maps, hey, I want to have 3 different options. I want to have the fastest route or the cheapest route, or I want to add a few stops on the road. And I can compare each of those routes in Google Maps, and it will tell me for each route, this is the time it takes for you to get there, and this is how much it will cost you. And based on my personal criteria, I can find the best option for my situation. We give something similar to the grower. For the grower, we give the ability to compare different cultivation scenarios, so different temperature strategies, fruit pruning strategies, and we simulate those strategies based on where the crop is today, and allow the grower to compare these strategies in silico, meaning in a digital way. So instead of trying, if the grower thinks, I want to try a strategy and having to wait a full season to see the effect, they can iterate on strategies on an ongoing basis to determine what is my best strategy. And they can do it before the season and also while going through the season and new information comes in, because growing is a very reactive sport. They can do this as well. Here you see an example in the bottom where we have a different pruning strategy and a temperature strategy, and we show the grower how this results in different fruit weight, for example. Now, to close off, AI is not a silver bullet. AI will not disrupt this industry, but it is a very useful tool for growers. AI will bring the future forward. It will increase the rate of innovation for the production, for the greenhouse vegetable production industry. And I do strongly believe that in 10 years, the world of vegetable production will consist of growers who were able to successfully adopt these type of technologies into their operation. Thank you very much.